A fundamental shift is happening in personal computing, and it is changing what matters most when you buy your next laptop or desktop. For years, graphics processing units dominated conversations about performance, but now a different type of processor is taking center stage: the neural processing unit. Neural processing units, or NPUs, are specialized chips designed specifically for artificial intelligence workloads. Unlike graphics processing units that excel at rendering images and handling parallel calculations for gaming, NPUs are optimized for the mathematical operations that power machine learning models. They handle matrix multiplications and tensor operations with remarkable efficiency, using far less power than their graphics counterparts. The reason NPUs suddenly matter comes down to how we interact with artificial intelligence. Large language models were once confined to remote data centers, accessed only through internet connections. But the landscape is changing rapidly. Local large language models that run entirely on your device are becoming not just possible, but practical and desirable. Running language models locally offers compelling advantages. Privacy stands at the forefront. Your conversations, documents, and queries never leave your device. There is no data sent to external servers, no logs stored in corporate databases. For sensitive work, personal information, or confidential business matters, this privacy guarantee is invaluable. Speed represents another crucial benefit. Local models eliminate network latency entirely. Responses appear instantly, without waiting for data to travel to distant servers and back. This responsiveness transforms how fluidly you can work with artificial intelligence assistants. Offline functionality means your AI tools work anywhere, whether you are on an airplane, in a remote location, or simply experiencing internet connectivity issues. Here is where neural processing units prove their worth. Graphics processing units certainly can run language models, and they do so in data centers worldwide. However, they consume substantial power, generate significant heat, and drain laptop batteries rapidly. A graphics unit might draw 50 to 300 watts when processing language model requests. This power consumption makes sustained use impractical on mobile devices. Neural processing units approach the same tasks differently. They achieve similar performance while drawing only 10 to 15 watts. This efficiency gap is not marginal, it is transformative. An NPU can process your requests throughout an entire workday without demolishing your battery life. The chip stays cool, the fans remain quiet, and your laptop remains genuinely portable. The architectural differences explain this efficiency advantage. NPUs feature dedicated circuits for the specific mathematical operations that language models require most frequently. They move data more efficiently between processing cores and memory. They sacrifice the flexibility that makes graphics units good at many different tasks, but gain tremendous efficiency at the one task that increasingly matters most. Major technology companies have recognized this shift. Recent processor releases from all major manufacturers now include substantial neural processing capabilities. Apple integrated neural engines into their silicon. Intel added NPUs to their latest mobile processors. AMD followed suit. Qualcomm built their entire computing strategy around neural processing performance. These are not experimental features, they represent a fundamental rethinking of processor design priorities. The performance numbers tell a compelling story. Modern NPUs can process tens of trillions of operations per second specifically for AI workloads. A capable neural processing unit can run a 7 billion parameter language model at conversational speeds while sipping power. Some can even handle 13 billion parameter models, approaching the capability of models that required data center hardware just 2 years ago. This capability enables entirely new workflows. Imagine writing with an AI assistant that understands your style, suggests improvements, and answers questions, all without sending your drafts to external servers. Picture coding with an AI pair programmer that runs locally, protecting your proprietary code. Consider analyzing documents, generating summaries, or translating languages with tools that work offline and keep your data private. The software ecosystem is rapidly adapting. Developers are optimizing language models specifically for neural processing unit execution. Frameworks now support NPU acceleration natively. Operating systems are integrating AI capabilities that leverage these specialized processors. The infrastructure for local AI is maturing quickly. For consumers, this shift changes purchasing priorities. A powerful graphics unit still matters for gaming, video editing, and three-dimensional rendering. But for knowledge work, productivity, and everyday computing, neural processing unit performance is becoming the more important specification. The question is no longer whether a device has an NPU, but how capable that NPU is. Businesses are taking notice as well. Organizations handling sensitive data can deploy AI tools without sending information to third-party services. Companies can customize language models for their specific needs and run them on employee devices. The compliance and security benefits are substantial. The transition is not complete, but the direction is clear. As language models become more efficient and neural processing units grow more powerful, local AI will become the default rather than the exception. The era of sending every AI request to distant servers will seem as outdated as storing all your files on remote mainframes. Neural processing unit performance now matters more than graphics performance for a growing number of users. This is not hype or speculation. It reflects a genuine shift in how we compute, how we interact with artificial intelligence, and what we need from our devices. The processors that can efficiently run language models locally are the processors that will define the next generation of personal computing. The rise of local large language models is not just a technical evolution. It represents a fundamental change in the relationship between users and artificial intelligence, prioritizing privacy, speed, and independence. And at the heart of this transformation sits the neural processing unit, the specialized chip that makes it all possible.